Magnetic hysteresis of a ferromagnetic is like an alteration of magnetization in relation to alternation of external magnetic field. Magnetic permeability of ferromagnetic materials is not a constant value, it strongly depends on the induction of the external field. Variable permeability leads to a complex nonlinear dependence of the magnetic field induction in the ferromagnetic of the induction of the external magnetic field. A characteristic feature of the magnetization process of ferromagnetic materials is the so-called hysteresis, in other words, the dependence of magnetization on the sample history. The magnetization curve of the ferromagnetic sample is a complex-shaped loop, which is called a hysteresis loop. It is sufficiently strong magnetic field, the ferromagnetic is magnetized to its saturation. As the field increases, the value of ferromagnetic magnetization remains virtually unchanged. If we then reduce the magnetic induction of the external field and bring it back to zero, the ferromagnetic will retain a remnant magnetization. The sample may be completely demagnetized only in a strong field of opposite direction, which is called the coercive field. As the magnetic field of the opposite direction increases, the sample is magnetized again along the field to its saturation. The sample is demagnetized from the point A to the point B, occurs according to the reverse curve. Thus, due to cyclic variation of the field, the curve characterizing the variation of the magnetic movement of the sample forms the loop of magnetic hysteresis. The coercive force and the shape of the hysteresis loop characterize the ferromagnetic properties to maintain remnant magnetization and hereby determine their use. Ferromagnetic materials with a wide hysteresis loop are called hard magnetic materials. They are used to create permanent magnets. Materials with narrow hysteresis loop and low coercive force are called soft magnetic materials. They are used to manufacture transform cores, generators and other devices which determine the remagnetization in alternating magnetic fields. Ferromagnetic materials with a very small area of the hysteresis loop have found wide application. One of the peculiarities of ferrites is that they do not conduct electric current, and their usage helps to reduce remagnetization energy losses.